The major goal of health-related AI application is to investigate the links between preventative or treatment methods and patient's outcome. AI programs are used in diagnosis, treatment protocol formulation, drug discovery, personalized medicine, patient monitoring and care, among other things. For illness prevention and diagnosis, AI algorithm can also be utilized to examine massive amount of data from electronic health records. In this video, introduction to artificial learning, machine learning, deep learning, and neural network is discussed, followed by the demo on regression and classification. Let's quickly start the video and learn more about artificial intelligence in health management. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Sci-fi movies. Most of the time, we see AI is depicted as a robot villain who will destroy our planet. But it is completely different. AI, in fact, is helping us in improving our life. Nowadays, with the evolution of technologies, we are robots who can perform any activities as good as it can be performed by a human being. AI is everywhere. For example, in the field of cricket, there are tools such as bowling machine who can bowl like Shoaib Akhtar, Del Steyn, any of your favorite bowler, and a batsman can practice in front of that and can improve his or her skill. Similarly, AI is doing tremendously well in the field of healthcare. Hello everyone, my name is Shrikant Kumar and I welcome you all to this course of AI in healthcare. So, without wasting any time, let's get started. So now let's quickly discuss the topics which we are going to cover in this course. In this course, we are going to cover what is in artificial intelligence, what are the timeline of artificial intelligence, how artificial intelligence evolved over the years, what is machine learning, different types of machine learning. Then we will be looking into a type of supervised machine learning. Then we will be covering what is deep learning, applications of artificial intelligence, how AI is helping the healthcare. We will be looking into some of the applications of AI in the field of healthcare. Then we will be covering how AI can be disastrous in the field of healthcare. Then we will be solving one AI-driven use case using artificial intelligence. Now let's try and understand what is AI. AI stands for artificial intelligence. So, what is AI? Whenever we heard the term AI, it comes in our mind that it's a robot. But it is not always true that AI is a robotic system. So, what AI is exactly? AI is a system with which we can give brain or we can give ability to think to any kind of a machine. So, with the help of AI, we can give brain to any machine with the help of complex algorithms. So these algorithms are various types of algorithm. We will see a couple of those algorithms in this session, and we use the statistics. With the help of statistics and the complex algorithm, we can find out the patterns or the insight from the data, which is we cannot see through our naked eye. So with the help of AI, we provided those insights from the data to machine, and then machine has the ability to think. So, for example, you can consider the example of chatbots. So, whenever you go to any website, you will see in their frequently asked question or in their services, you will see an option of chatbot. So, you can chat with the bot. You can tell them your issues or whatever, if you want to know any queries. And based on those queries and based on those feedbacks, the chatbot will respond back to you. Similarly, face recognition. We do use mobile phones. Mobile phones have certain features, something like that screen lock with the help of face. If you smile, your mobile will get unlocked. If you smile, mobile will get locked. Similarly, recommendation system. Now it's an era of OTT platform. We all watches web series, movies on OTT platform. But have you ever thought how OTT platforms are they are just reading you, or they are just trying to understand your patterns, the type of movies you watch, the type of web series you watch, the type of stand-up comedy you watch, and based on that they recommend movies, web series, or any kind of telefilms to you. So these are some of the examples of artificial intelligence driven systems. The next thing is AI timeline. Before going into AI timeline, let's discuss what is the life cycle of artificial intelligence. So broadly, we can segregate artificial intelligence life cycle into three forms. One is design. The next phase is called development. The third phase is called deployment. So in design, develop, and deployment, further we can segregate them into seven different forms. So let's look at them one by one. So the first is identify and formulate the problem. In this section, what do? We just get the business use case, and then from that business use case, we try to analyze that what is the user has asking in this problem to solve. Then based on that, we try and identify if there is any solution available in the market or not, and then based on those results, we move to our next step. The next step is review AI lit, that is ethics, algorithms, and pre-trained model. In this, we do check all the ethics of AI. Then we check what are the algorithms we can use in this problem statement, and whether there are any pre-trained model available in the market or not. If there are any pre-trained model available, we will directly use them. For example, in image processing, we use ResNet, or we use ImageNet, or we use efficient network. So there are so many pre-trained model available. Similarly, in terms of natural language processing, we have transformers. So then we move to our next process, that is data preparation. In this process, we do gather the data. We do all the basic pre-processing like cleaning the data, removing the null values, and things like that. Then we do the data exploration. In this, we do try to find out what is the variance of the data. Is there any data variance with respect to the target or not? And things like that. We do basic statistical analysis here. Then in the next step, we do identify, do we need any external data from outside? For example, do we need any social media results from for performing this action? For example, if you want to create a Reddit chatbot, what companies usually do? Company will gather the data from Reddit. So that is known as external data acquisition. After that, we do the data wrangling. In data wrangling, this is similar to the EDA, where we do the data mangling, okay, and then from that data, we try to identify the information and we get the result from it. Then the next step is data augmentation. So data augmentation is a process in which we try to generate data synthetically. So what does it mean? We try to change the data by changing a very minor value in the independent variable, and based on that we try to create a more dependent variable. By this, we enlarge the size of our data. The next step is build initial AI model. So then we do create a basic modeling, which will be becoming like our base model for this use case. And then we do develop a benchmark. So what will be our parameters? Based on that, we will be judging that whether my model is good or not, whether it is performing good or not. So once we create the benchmark, we build multiple AI models. So in this, we do try to apply various algorithms in this step so that we get multiple solution for that. And based on that, we will be judging the model with the help of benchmarks and evaluating the primary metrics. Then with the help of that, we identify that which model is performing well. Once we get that which model is performing well, we do the explainability. So in this explainability, what do we do? For example, suppose you have a image in which you want to identify whether it's a cat or a dog. So when you build your AI model, So that AI model is using some features from that image. Based on that, it is identifying whether the image is of cat or it's an image of dog. So how can we get those features? So for those features, for example, we use GradCam in terms of image processing, in terms of any machine learning model like random forest, decision tree. We do build the tree and we visualize the tree, we visualize the variable importance, and based on that we identify that how model is doing the classification or regression or recommendation or things like that. Once we do this, we move to the last portion, that is deployment. So we do evaluate the model based on the secondary parameters. After doing it with the primary parameter, we do check with the secondary parameter. Once the model is also performing well with the secondary parameter, we do the deployment. So in deployment, we create an API and we use that API to perform the or to get us the result. Then we do create a ML pipeline, ML ops pipeline, or we do create an AI ops pipeline. Once we create these AI ops pipeline or ML pipeline, we the next in the next step we try to build a system such that it can perform activities on cron data. Okay, so it can automatically perform, for example, if once in a day, twice in a day, or at some customizable timings, it can do the training, it can predict the results for us, and or it can get the result and send it across the group as an email and things like that. Then at the end, we do monitor and evaluate the performance. How model is performance? That does not mean after deployment we will stop developing the model. Once we deploy the model, then we do on a recurring basis, we do identify that how model is performing. And based on that, we plan for retraining and other things. So this is a complete pipeline, or we can say life cycle of AI, and this is never stopping. It's kind of a circular motion, it is moving in a circular motion which will be continue forever. Now move on to our next topic, how AI has been evolved over the years. So we have here group them into 5 groups. That does not mean in the other years it didn't perform, or there were no development in this, but these are the years when major achievements, or there were major activities which transformed the AI completely. So let's take the first era, that was 1950 to 1960. In this time, first neural computer was introduced. This was done during the Second World War. There were a few activities which were done by the armies to save their data. That time, the neural network concept was introduced, and in during the 1950 to 1960, Alan Turing also invented or developed the Turing test. In 1961 to 1960, during that time, industrial robots were introduced. ELISA chatbot was developed by MIT and university. Then in 1991 to 2000, emotional intelligence robot Kismet was introduced. And at the same era, Sony launched a pet dog robot called AIBO. During 2001 and 2010, IBM's Watson was introduced. Apple Siri was introduced. Amazon introduces Alexa. Then Iguin passed the Turing test. So Iguin was nothing but it was a robot who passed the Turing test. During the 2010 till present, we saw so many movements in the field of AI. Google introduces self-driving car. Tesla has a car which is performing very well. Google introduces Google Assistant. We do see the Google's Smart Compose introduced by Gmail, then language translation by Gmail, and things like that. And then many things have been done during this time. This was we can say till now, this is the best era in which most of the things were done, and we are in the field of AI. The position where we are right now is was not possible without we pass this era. So these were some of the crucial moment or crucial time for the AI timeline. What is machine learning? Whenever we heard the term machine learning, people consider it to be a magic. So some of the folk thinks that it's a magic. ML can do anything, but that is not necessarily true. What ML does instead of that, suppose we have a data. So it is not possible from our identify the patterns which are present in that data. So what ML does, ML takes help of maths as well as it takes help of statistics. So with this statistics and mathematics, it tries to find out a formula, or it identifies the patterns from the data, and with the help of those patterns or the formulae, what machine learning does all the predictions. So we can say machine learning is nothing but process which provides an ability to a computer to read any patterns or to identify the formula from the historical data, and based on those historical data try to forecast, print, or do any kind of activities which we can do without any human intervention. And machine learning is a subdomain of artificial intelligence. So if we draw a Venn diagram of AI, so this is AI, this is ML. So AI. So we can say AI is superset of machine learning. We do see some examples of machine learning in our day-to-day life. For example, stock market prediction, weather prediction. We do use mobiles. In our mobile, we every day we see that what is the probability of getting rain today, what could be the humidity rate today, what could be the maximum temperature or minimum temperature, and things like that. Then we do also identify the sentiment, we can find out the sentiment analysis. So in sentiment analysis, with the help of text, we do identify whether it's a positive sentence or it's a negative. So this kind of a thing we can perform in sentiment analysis. The next thing is customer segmentation. So suppose you are using a ABC bank credit card. Okay. Now that you are every year you are spending 10 lakh rupees. So based on those 10 lakh rupees, since you are spending 10 lakh rupees, so company will give you that since you are using this much amount of money, so you will be in the A plus grade and you will get certain facilities from the card. If someone is using 5 lakh, they will segment it into B group or A group, further B group, C group, and D group, and then things like that. Based on the expenses you are doing, company can segment you into various customers. So these kind of a thing without using any human intervention, with the help of machine learning, we can also perform these kind of a things, and these kind of solutions are existing in the industry. What are the drawbacks of machine learning? In order to train a machine learning, there must be a huge amount of data with variation in the data, and data should not be biased. So what does it mean? So when we are training a machine learning model, we need data, and that too it should be large. And when we are training a data, then there should be a variability. There should not be, if there is no variability in the data, we cannot train our machine learning model, and it should not be biased towards the data. Suppose you are training a model that has where you are supposed to segregate customers into one group only, or suppose you are segregating groups of people into two, but you have 99% of data which belongs to one group and only 1% belong to the second group. So in this case the data is biased, or we can say skewed towards one. So we cannot train such kind of a model, or if we want to train such kind of a model, we do need to either oversample this, or we do need to undersample this data, or we need to synthetically generate the second group of data, and then only we can train it. But these type of model does not work always well. Now moving on to next topic, there is no fixed thumb rule in selection of model. In machine learning there are so many models available in the market, but which one to pick? You cannot pick randomly anyone, or you cannot say only AdaBoost will work best to the any kind of a data, or let's say a random forest will work for you only best, or logistic regression will help you, or linear regression, or polynomial regression. So you cannot have a thumb rule to select a model. So this is a manual task, which is a drawback from machine learning. Then another problem is, in order to train a machine learning, we require a compute capabilities. So suppose you are training a machine learning, then you need a compute capabilities, which involves costing. So if you train your model and the model didn't turn well, so in that case, your costing will go in vain. So whenever we are training such kind of a model, we do need to see what could be the feasibility of that, or what is the ROI we are getting it from the. Then there is one more problem, that is called, we cannot directly, or we cannot identify, or we cannot define how model is either classifying or doing the regression, or how it is coming to the conclusion. So the data explainability is a difficult task, or sometimes we see that we are unable to tell the audience that how model is doing the prediction, or how it is coming to the conclusion. So sometimes it becomes a black box to us. So that is also a problem of a machine learning. Now let's move on to our next topic, that is types of machine learning. So what are the types of machine learning models? So machine learning can be divided into two groups. Basically, we can divide it into a supervised machine learning or unsupervised machine learning. There is one more type of machine learning, that is known as reinforcement machine learning or semi-supervised machine learning. But for the sake of this course, we are considering only two types of machine learning problem. So what is supervised machine learning? Whenever we get a data, if we have independent variable as well as if we have dependent variable, then that kind of a problem is known as supervised machine learning problem. So in supervised machine learning, the data consists of input and output as well. The goal of supervised machine learning is to draw a pattern between the input and the output of the data. Supervised machine learning is further divided into regression and classification, which we will be seeing in coming slides. Now, next, move on to the unsupervised machine learning. In unsupervised machine learning, there is only input data, or we can say independent data. We don't have dependent data in unsupervised machine learning. The goal of unsupervised machine learning is to chunk input into groups. So suppose you have 100 data given, then in this, what you will do, based on the types of data, or what is the variability in the data or the patterns, you will segregate data into 2 groups, 4 groups, 5 groups with the help of elbow method. In supervised machine learning, the system learn on its own. Since we do not have the output data, so the system automatically, or with the help of statistics and mathematical formula, it identifies how to group the various data into different subgroups. Now let's move on to our next slide. What are the examples of supervised machine learning? In the previous slide, we discussed supervised machine learning can be divided into 2 groups. One is classification and another one is regression. So we do see the image classification in our phone. For example, if you use Google Photos, so what Google Photo does, when you provide it that who is present in this photo, the next time it will identify automatically that person, and it will group that person into that class. Another example is text classification. So in this, by providing input text and output to that machine learning model, we do train classification model for text data, and that classification model can identify, by providing a new input to the data, it will segregate, or it will classify the data into any of the group for which machine learning model has been trained. The another examples of supervised machine learning is in terms of regression, sales prediction, house price prediction, temperature prediction, and rainfall prediction. So let's discuss some examples of unsupervised machine learning. customer segmentation, topic modeling, text clustering, segmentation of image, manufacturing defect detection, fraud detection. What are the types of supervised machine learning? So, in supervised machine learning, before we go into regression and classification, let's discuss what are the types of data. So, basically, we can divide our data into two types: numerical data or categorical data. When we perform some activity to measure, or we are quantifying something, for example, measuring someone's weight, measuring someone's height, that type of data is numerical. The numerical data can be continuous or discrete. For example, let's suppose we are identifying how many male and female are present in a group. So their frequency will become, for example, 20, 30 out of 50, or it can be 25, 22, and 27. It can be 25, 25. So things like that. So these are nothing but discrete. These are type of discrete value. Another type is continuous. So suppose when you are measuring the today's temperature, so in the thermometer, when you are measuring it, can you precisely say that it's a 37 degree only? No, you cannot say. It may be possible that it is 36.999999, or it can be 37.00001. Is it 37 precisely? No, it is greater than 37. Similarly, it is lesser than 37. It is tending towards 37, but it is not exactly 37. So these kind of data are known as continuous data. Now let's move on to our next type, that is categorical data. Categorical data can be segregated into groups. There is finite set of discrete values of a group. So suppose if we have a group of data where we are identifying that whether it's a cat or it's a dog or it's a horse. So since we know that all the possible animals in the group, so we can say that discrete values are countable, or they are finite in nature. We cannot say that it's a infinite. So some of the examples of categorical data are gender, race, city, rating to any movie review. So things like that, we can consider it as a categorical data. Now let's move on to our next slide, that is what is regression. Initially we discussed that we have input and we have output. So these kind of data are known as supervised machine learning. In regression, with the help of statistics, we try to establish a relation between independent variable, that is our input, and dependent variable, that is our output. Regression is a supervised machine learning. In regression, the output variables are numerical in nature. We can say that these are continuous. So suppose, for example, by providing the experience, suppose we want to identify the salary of individual. So this is an example of regression. Or suppose by providing the age of mice, we can say that what could be the possible weight of the mice. So these are some of the examples of regression. What is classification? In classification, with the help of statistical models, we try to establish a relation between independent variable and a dependent variable, and we classify the data. Instead of getting a continuous value, we classify them into discrete values. We try to identify them into discrete value. Classification is a supervised machine learning algorithm. Since we have independent data and dependent data, so we can say that classification is a supervised machine learning algorithm. In classification, the outputs are categorical in nature. Let's suppose identify whether a image is of a cat or it's a image of dog, or let's say whether the person will become diabetic or non-diabetic. So these kind of use cases are comes under classification. What is deep learning? Till now we have covered what is machine learning, what is artificial intelligence. Now let's move on to our next topic, that is deep learning. So deep learning is a subset of machine learning that has taken over the world as a leading technology today. So if we try and draw the Venn diagram of AI, this is AI, this is ML, and this is DL. It imitates the complexity, or it imitates the complex functionality of human brain to use unstructured data to describe meaning and teach machines. So it uses particularly a term that is known as neuron. So what we do in machine learning, we try to generate a formula. But in machine learning, in terms of deep learning, we try to mimic a human brain that is known as neurons. And with the help of those neurons, we segregate, or we try to find the pattern in the data without doing any kind of cleaning to the data. It automatically identifies the features, the important variables, with the help of which it can generate the result to us. From industries like automotive, healthcare, security, to content creation, the application of deep learning are many and are on rise. Every day we are getting a new technology, a new algorithm in terms of deep learning, and this is doing nothing. It is helping us in solving the problems which are not solvable, or which are solvable but which are not efficient enough by machine. We can do it with the help of deep learning. To mimic human brains, neural network uses, or deep learning uses, the concept of neuron, which are the basic building block of our human brain. So basically how this happens. So when we have input, these are nothing but the features. So we give all these features to the model. Then these features goes to the input layer. Here suppose we have a input layer, and that input layer provides weight to all these values. So there will be multiple neurons, and those neurons will get weights, and these weights will be given into some other layers. In between those layers there will be hidden layers, and then we will have the output layer. We will get the output results. So how this happens, or what happens in between this field, that is known as hidden layer. So what typically happens, that when we give input x to input layer, this is known as our input layer. So here we have so many neurons, and these inputs, I'm not going to create the for each of the neurons will be connected to the various other neurons, but for the sake of simplicity, I'm not going to create those layers. So then there will be second layer, then there will be third layer, and there will be so many hidden layers. So these are nothing but hidden layers. So the layers between our input and our output are nothing but hidden layers. So in these hidden layers, what happens, that these all these lines with which two neurons are connected, let's suppose there are three neurons and there are two neurons. Suppose this will connected to this is connected to this, and this is connected to this one is connected to this, and this one is connected to this. And there is weight, arbitrary weight given to each lines, w1, w2, w3, w4, w5, and w6. And these neurons will be again further connected to the other neurons. There may be chances that they are fully connected, or there may be a chance that they are not fully connected. These are can be decided with the help of activation functions. So if you are interested, or if you want to know further more about them, or how mathematically these things happens, I would encourage you to go to the GLA Academy. There you will be finding video tutorials related to how deep learning actually works mathematically. So from these, now let's come to our topic. Now, in these layers, what happens that their calculation happens and weight value changes, and after that, once we get the output, these output will be judged with the actual output, and based on those actual output, there is a field which is known as optimization. So that optimization penalizes the learning rate to the model, and and what it does, it changes all the weights of the neurons. So all the weight of the neurons will automatically changes with the help of optimization, and then again retraining for the next epoch it will run, and based on that, the result which we get, it will change the weights, and these things will work forward propagation as well as backward propagation, and at the end of all the epochs we get a trained model trained model, and with the help of that we can do the prediction with the help of this. So this is the basic structure, or how any kind of a deep learning model or artificial neural network model works. Now let's move on to our next slide. What is CNN? CNN stands for convolutional neural network. CNN is a type of neural network which works well on image kind of a data, but that does not necessarily means that it cannot work on numerical data, or it cannot work well on text data. But it has been seen that if we are applying CNN to image data, it performs well. CNN data consists of input layer, output layer, hidden layer, which includes convolutional layer, pooling, dropouts, normalization layer. So now let's suppose we have one input data. This is an image. So this image will convert into array. So we know that image's smallest value is pixel. So these pixel values ranges from 0 to 255. So from that image, we do create an array which ranges from 0 to 255, and that will be the input of our system. So that input goes to the input layer, and from that input layer, it goes to various convolutional layers. In convolutional layers, or in convolutional neural 2D convolutional layer, what happens typically that we do get the feature maps, and these feature maps are generating dot products with the help of these kernels. These kernels are nothing but these are either 2D or 3D in nature, and these are weights. So from these weights, we do multiply the feature map, and we create a dot product of it, and as a result, we generate further new convolutional layers, and those convolutional layers again will apply the dot product with the kernel, and at the end we get a fully connected layer, and in that fully connected layer we do apply activation functions, like based on the type of data. If it's a regression, we do apply linear. If it's a classification, we do either apply softmax, sigmoid, relu. So there are various activation functions in deep learning, we do apply them, and at the end we get the output. So there is a term that is known as convolutional layer. We discuss this convolutional layer. In this convolutional layer, we do multiply the feature map, or we create a dot product of feature map with kernels. So these kernels do multiply, and they create a dot product. Then next comes the activation function. So there are typically four activation functions which are widely used. One is relu, one is tanh, one is sigmoid, another one is softmax. So softmax ranges from 0 to 1, sigmoid ranges from 0 to 1, tanh ranges from -1 to 1, and relu ranges from 0 to maximum. So How these works, let's discuss one by one. Whenever we apply ReLU, what it does, it from the matrix, it identifies whether the value is maximum or not. Okay, and from that value, if any value is negative, the ReLU will return either 0, or if it is not 0, then that positive number will be the output of ReLU. Then comes the tan h. When we apply tan h, it converts the value into either -1 to 1. Then next is sigmoid. It produces the probability or the likelihood of any result. So it ranges from 0 to 1. Similarly, softmax also produces from 0 to 1, but these are not like sigmoid. What it does, it tells, like for example, we are identifying whether the image is of a cat or it's a image of dog. So sum of the probability of these two will become 1. So if we apply at the last layer softmax, so what it will tell you, it will tell you that let's suppose the probability of occurring of a cat is 60%, then the dog will be 40%. So in total they will be some 1, but sigmoid is not like that. Next is padding, in which we do our matrix, we pad it with 0. Okay. Next is strides, pooling. In pooling, we do apply kernels. Okay. These are nothing but pooling methods. Okay. In which we pull, either we pull maximum value or we pull average value, and things like that. And by doing so, we reduces the size of the matrix. Then comes the dropout. Sometime what happens that whenever we are training any machine learning model or deep learning model, what typically happens that our model get overfit. So in order to avoid the overfit of model, we do apply penalty to model by applying some dropout layer to that. Then next comes the fully connected layers, learning rate. These are the penalty which we provided after performing the optimization. Then epochs. Epochs are nothing but how many times we are going to train our model. But it is similar to a for loop, but not completely, because it applies the forward propagation and backward propagation as well. Then comes the optimization. We discussed about optimization and how useful optimization is in training our machine learning model. Now let's discuss how we can solve a regression and a classification problem in deep learning. For this purpose, we will be using TensorFlow, Keras, and we will be using Jupyter Notebook under Anaconda environment as a ID. So without wasting any time, let's see you there. Now let's see how we can solve a regression problem using deep learning. For this purpose, we are using this data, house price advanced regression technique, which you can find it out from kaggle.com. So now, without wasting any time, let's get started. So now first, we will load the important packages for the data. So here we are importing NumPy, Pandas, Scikit-learn, Keras, and we are using Matplotlib for visualization, Seaborn. Okay. So now we have our data here. So we will load this train data. So now our data is loaded. Now let's see how data looks like. So we can see here there are 10 rows and 80 columns. So here we have so many columns present here. Now let's do the data description. So what data description gives you? Data description gives you the statistical view of the data, or it gives you the how many values are present in the data, what is the mean of the variable, standard deviation, minimum value, maximum value, what is the proportion of 50% of the data, 70% of the data, what is the maximum value of the data. So these gives you statistical information. So what we can understand from it, that we can apply these describe on numerical data only. So from this data, we can see that let's describe the sales price. So if we see this, we can see it here. The mean is $180,921.19. But if you see carefully, you can see that maximum value is 755000, but 50% of the data lies between 163000. That means if we plot a normal distribution of the curve, we can say that the data will be lying on the left side, or it's a left skewed. So now let's plot this. So if we plot it, as we already discussed, that majority of the values are ranging is in these regions. So we can say that the data is not normally distributed, or it's a little bit left skewed data. Now let's see the correlation plot. So what correlation provides us? Correlation provides us what is the relation between the two variables, or we can say how we can identify one variable, or how one variable is associated directly or indirectly to the another variable. So for that, let's plot this. So if we plot this correlation plot, here there are so many variables, it's little difficult for us to come to a conclusion. But what we can say here, we can say that basement area and the area of the first floor, so these holds more or less same kind of a data. So for example, this is basement area first floor, and these are pretty much associated to each other. It's little difficult for us to identify it with the color, but same goes with the garage variable. For example, if you have a big garage, so you can have more number of cars in your garage, which is common sense for us. If the carpet area is large, we can have large number of cars there, so we can drop either of them. So now let's, since here we are plotting it for all the variables and it is becoming difficult for us, so now let's plot it for 10 highest correlated variables with sales price. So if we plot it, so we can see that, for example, let's see that the sales price and the overall quality. So we can say that it's a 0.79, which is highly correlated. Similarly, if we can see here this garage living area, ground floor living area, and the total rooms above ground floor, these are also highly correlated. So what we can do, we need to delete such kind of variables which are highly correlated to all the variables but not sales price. Okay, so by doing this, we can have our crisp data, or we can do the data pre-processing first steps. Okay, so now here we can see that overall quality, gr living area, and total basement are important. From garage car and the garage area, we can drop either of them. So let's see, for example, garage cars and garage area. Now we have garage car and garage area. So we can see that these are 88% related to each other. So we can delete either of them. Similarly, from total basement SF and first floor SF, we can drop either of them. And from total room above ground and GR living area are also highly correlated. So we can drop either of them. For example, here we are removing total RMS above ground. So now let's see whether our data has any missing values or not. Since machine learning, deep learning models cannot work with missing values, there are certain algorithms like KNN, random forest, who can automatically do the data imputation, but other algorithms have not ability to do. So let's see first how many values are, or the percentage values which are missing here. So from these data, we can see that there are certain values for which, for example, we can see that the missing values count here. Okay, and the percentage of the value. So what we can do, instead of using any imputation method, we will directly impute it with the mean of the train data. So let's execute it. So now we have our train data ready. So now let's do a data scalarization. Okay, for that we will be using standard scaler. So for that we will create an object of standard scaler. Then that standard of scaler will fit on cell price, and then we will create a cell price scaled. So let's execute it. So now we have executed this. Now, if you see, earlier we were having sales price as uh, these numbers, but now it is ranging from -1 to 1. So why did we do that? So suppose we are having two rows, okay, x1, x2. So they have certain values like 50, 40, 20, 10, and 1. Okay. Now, from that, we can say x2 is equals to 2 times of x1. Okay. So, if the value of x1 is large, then we can say x2 will be large. Okay. But when we are training any machine learning model, we cannot do that. So by doing this, what we can do, we are introducing bias. So for some values, we are introducing bias to some of the data points. So this way, our model will not be unbiased, or our model will be biased, so that we will not get a good result. So we need to take care of that thing, and we need to remove those issues. So for that, we do either use normalization, or we use standard scaler. For this, we have used standard scaler. So now you can see that the values are ranging from -1 to 1. Now let's see. Suppose we want to choose these much variables like sales price, overall quality, ground living area, garage cars, full bath, and year built. Okay. Now we create a train data. From that train data, we will be creating a df underscore train. For that df underscore train, we will be doing the one hot encoding. So from after that, we will be removing the null values if any null values are present. Then we will be doing the scalarization of data using the standard scaler. After that, we have that our train ready, and we have done this to our sales price. So now our y is sales price, which is our dependent variable. So now we have all the feature variables ready. These are our feature variables, and this is our dependent variable. Now, with the help of train test split, we will divide the data into two parts. Here, we are dividing it into 67% as a train data and 33% as a validation set. Now, let's create a model. So first, we will be creating a model, sequential model, and then to that model, we will add a input layer, and we will provide our input to it. So these are input layer. Then we will be adding a dense layer with activation function as a ReLU. Then to next, we will be adding one another dense layer. These are nothing but these are hidden layers. And here also we are using ReLU. And at the end, this is our output layer. So to this output layer, we are providing a dense layer, and the number of neuron to this is 1. Since regression is a problem in which we are getting a continuous values, so here we will not be using any activation function. If it was a classification problem, then based on the type of classification problem, we would be using here activation as a either sigmoid or softmax. We will see when we will be solving the classification problem how different it is at the end only. Then we will do the compilation of our model, and we will be using optimizer Adam, and then loss function which we are using, based on which we will be identifying whether our performance model is performing well or not, that is mean squared error. And our matrix is matrices dot mean absolute error, and then we create a return a model. So now execute it. Now let's create a model or object of the model. Name model. Let me execute this first. Now we have our model ready with summary that what is layer, what is the output shape. So from this we can see that our model is ready. Now with the help of model.fit, we will be training our model. And here what we are doing, we are giving the input as train x and we are giving the output as y underscore train. Then we are providing the validation data and what we will be using with the validation data. With the help of validation data, model will use the optimization and it will optimize the model, that how it will change the weights of the model to get a better result from it. Then we will be using here epochs as 150 epochs. So that means to and fro, back propagation, forward propagation, it will run 150 times each, and our batch size is 32. Now let's execute it. So we can see that with the loss, we can identify that our model is converging. Suppose initially the loss was 0.72 and validation loss was 0.58, but then it drastically changes to 0.33 and 0.34. Now let's go to the end of the model. Now we have completed our 150th epoch. Now we can see the loss is 0.1057, mean absolute error is 0.23, validation loss is 0.28, validation mean absolute error is 0.31. So we can say that 0.23 and 0.31, there is not a large difference between them. However, we can understand that from the validation loss and the loss, there is a difference of 10 points. So we can say that the model is not a optimal one. But yeah, our purpose here is to understand how regression works in deep learning and how we can do the regression using Keras. So now let's import the train data and we will be predicting the values for that. So now let's create a train test df, and then with the help of predict function, we will be providing the input features to the model, and we will be getting the prediction for all the data points. So now we get those data points. So now let's see the data points. Since we had trained our model on scale data, so our y was also scaled that time. So we need to inversely transform these data to its normal form. So what we will be doing, to this object sales price scaled, which we had defined initially here, and we fit it and we trained it using fit method. So what we will be doing, with the help of this method dot inverse transform, we will be transforming inversely. Let me just execute this. So now if we plot this, we can see that the numbers, earlier it was from -1 to 1, but now we have numbers in positive. Now let's store it into a result. Now we can see that the IDs and corresponding sales price are there. By this way, we can perform a regression model. Yeah, as I mentioned earlier, this is not the best model, but yeah, we can improve it by adding some layers to it, by adding some neurons, and by tweaking the model, we can get a best result out of this model. But the process would be the same. Now let's see how we can do classification in deep learning with the help of TensorFlow and Keras. So first we will load the data and the packages which are necessary. So here in this data we are using MNIST data. So let's load the data. Now let's see how the data looks like. So the data is nothing but pixel values of the input images. So what MNIST data consists of? MNIST data is data which has input, which are handwritten input data, and our task is to identify the handwritten digit with the help of these pixel values. So now we can see that data. So now we will be dividing this data into two parts. One is train and one is test. So now we have divided the data into two parts. Now we need to reshape the data. Okay, so reshape the data, and then in order to normalize the data, what we will be doing, we will be further dividing it by 255, since we know that the maximum value of any pixel is, or the color can be 0 to the range of the values are from 0 to 255, and since we want to normalize them, so we will be dividing it by 255. So now let's do this. Now we will be creating a categorical data. Since it's a classification data, here the number of classes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is total 10 classes. So now with the help of NumPy utils to categorical data, we will be we will be creating a categorical data. So now let's see, for example, y test. So we can see that it's a one hot encoded data. Like for example, if you see this, this is 0, 1, 2. So this value correspond to our value 2. Now let's train a basic model. So first we will create a model object, sequential model object, with the help of function sequential. To this model, we will be adding a dense layer with 32 input layer, and input dimension is 28 cross 28, since we had created this data as a 28 by 28. So we will be passing the input data matrix as 28 cross 28, and the activation is ReLU. To this, we will be adding another dense layer, and at the end, since we know that the number of classes here are 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our input neurons would be, for the output layer would be 10, and activation function is softmax, because it's a multiple classification. Here we have multi labels. Labels are ranging from 0 to 9. We will be using activation function softmax. So now create a model. Then now let's compile this model. Since it's a categorical data, so loss would be categorical cross entropy, and optimizer is Adam, and matrix we are using as a accuracy. So now this is our model summary. So our model is ready. With the help of model.fit, now let's train the model. And for this model training, we are using 10 epochs with 100 batches. So now let's execute them. Now we have our training is done. So now let's get the score, or how the model has performed. So now we can see that the accuracy, or we can say that model is 96.95 times it is accurately predicted for the test data. So that's it from classification point. Our intention was to know how we can divide the data, or how we can do the regression and classification using Keras in deep learning. Now let's discuss some of the application of artificial intelligence. In our real life, we do see some of the applications, such as in our day-to-day life, we do Google search. We use Smart Compose from Gmail. Outlook also provided such kind of a thing, where by providing some input, we get the next generated data. For example, if you write thanks, it will automatically generate and regards. So it gives a feel good factor to user. Similarly, we do use the Google Translation. Suppose you know English, and or suppose you went to France. So since you know English only, and in France people mostly use to talk in French. So how you will communicate with them? So will you learn French there? It's a very difficult task. Let's imagine if you have went there for 10 days or 5 days. So it's not a good idea to learn a language for 10 days, because we cannot learn them. So instead of that, we can use the Google Translation. So Google Translation, what we will be doing? We will be providing our input text to the model. or to the data, to the system, and it will generate the French for that. Okay, so we do use Google Translation in our daily life. Then there is an example of self-driving car. Google as well as BMW, Mercedes, Tesla, they all provide self-driving cars. So there you don't need to worry about that whether you know driving or not, or whether you are sleeping or not. The car or the bus or the truck is self-automated or knows when to accelerate, when to press the clutch, when to change the gear. So things like that, and it automatically does without any human intervention. Similarly, we do use hardware solutions like Fitbit. We use Google's smartwatch, Apple smartwatch to measure our foot, how many steps we have covered, what is our heart rate, what is my body temperature, what is oxygen level, and things like that. And based on that, we can take measure decisions to being healthy. Similarly, there is a glucose meter system. So what glucose meter system is, for example, I'll take the example of Abbott. So Abbott has created a sensor kind of a thing which has sensor inside it, and you just need to paste it in your arm, and that will automatically measure your glucose rate, what is your consumption rate, and based on that, after assessing all those data, it will suggest you what kind of meal you should take, whether your glucose levels are under control, or what could be possibility of food consumption what you are doing right now, what is the future impact of that. Similarly, it can tell you what could be the like best way to tackle the glucose to diabetes kind of a thing. And then we see some other examples like chatbot. Okay, so where we have a system which will talk to us directly. Okay, and we provide our input to it. Okay, and from those input data, based on the correct output, now next is chatbot. So what chatbot does, in initially we discussed about chatbot that it's a system kind of a thing where instead of a person, robot, a chatbot is talking to us. So whatever our query, so for those queries, they resolve or they provide the solution to that. And there are other examples of AI driven solutions which we use in our day to day life. Now let's move on to our next slide. AI in healthcare. So there are so many applications which are available in the market for healthcare, which are driven by AI. Some of them are diabetes prediction, appointment prediction, breast cancer prediction, pneumonia prediction, cataract prediction, anomaly detection, and genome sequencing. Now let's take them one by one. So, what is diabetes prediction? So, based on the historical data, model is created in AI. So, based on this historical data, AI driven solution is generated and your information to it. Like, for example, what is your age? Is your paternal side or maternal side are diabetic or non diabetic? What type of job do you do? Okay, whether it's a sitting job or like you go from one place to another place, how much do you work out every day, and things like that. And based on that input, since it is trained on those previous historical data, it will say that whether the person can be a diabetic one or a non-diabetic one. Similarly, we saw during the COVID time, we saw the crunch. We saw that the getting the appointment from the doctors were very difficult. People were standing on lines to visit the doctor. But what if we have a solution in which we can directly go to a portal, and then in that portal we feed our information that what are the problems I'm having, and based on that it will generate a result for you, that to which doctor you can visit, or what is the probability of getting appointment from a particular hospital. So based on that you can prioritize, and then you can go to some particular hospital and you can get it diagnosed. Similarly, breast cancer prediction. So breast cancer prediction or pneumonia prediction or cataract predictions. These are some of the use cases where we provide the input as a image, and that image goes to an AI system. And that AI system, what it typically does, it identifies that what is the likelihood of getting that disease. So, based on that, we cannot say that a person is suffering from breast cancer or suffering from pneumonia or a cataract disease, but we can identify that what is the rate, whether it's a 90% chance that the person is having a cataract, or there is a chance of 10% that he has a cataract or she has a cataract. So what these can be done based on these probability values, appointment can be given to the those patients who are suffering more. Okay, so by doing this, we can help our hospital system to identify the more critical situations, and based on that they can serve them and they can save the people's life. Similarly, anomaly detection. So in some of the hospitals, what happens that whenever we are giving medicine to any patient, instead of giving it manually, there are systems which provide medicine to the patient. Similarly, nurses or the ward boys, they what they do, they help the patient to get the medicine. So while doing those medicine, whether the nurse has followed all the precautions or not, whether the oxygen was given to the patient or not, or things like that, whether the catheter was changed on the proper time or not, based on that this can be identified that whether it was an anomaly or it was not an anomaly. So with the help of that, we can help the healthcare system to take up preventive measures to avoid such situations. Similarly, there is a genome sequencing. Whenever any pandemic comes, or whenever we see the any virus effect on our human body, in order to generate the vaccine for that disease, we do the genome sequencing. We try to identify, we check the sequence of the proteins, and based on those sequence of the proteins, we do create the vaccines for the diseases. So these way, like genome sequencing is one of the very important use case of AI, which we are using in healthcare very frequently. How AI can be disastrous in healthcare. So, suppose we have built model in AI that can identify from the X-ray of a patient that it's a COVID or not COVID. And suppose some hospital is blindly following that machine. They have they think that the model is performing 100%. Okay, or the model's outcome is 100%. So in such situations, there may be a chances that the model is performing well, but there could be some scenarios where the model is not able to perform well, and we can segregate some of the patients into a wrong group. Similarly, there can be a possibility that whenever any pandemic or any disease comes in disease data, let's suppose we have 100 data. Then out of those 100 data, mostly in normal scenarios, we see that 90% of data is uh, negative. Okay, or we can say that it is not disease, and 10% of the data is disease, or we can say that the patient is suffering from a disease. Now let's suppose we have trained our model, and we discussed in the very beginning of the model that we do set some performance matrices. Okay, now suppose we set it accuracy as a model's performance, okay, metrics. So now suppose 90% and 10%, and whenever we are feeding the information or the data to the model, and we trained a AI model, okay, and we provide test input, okay, or let's say live data of a patient, okay, so there is a high chance that the model will be biased towards this negative one. Okay, and by doing so innocently or without knowing actual reason, we are saying that the patient is a negative patient, or we can say the patient is not suffering from that disease. Now let's suppose it's a blood cancer and we say that it's a negative one. What could be the like outcome of it? It will be very disastrous. So while creating a AI model or while creating a AI system for healthcare, we need to take care of such things, as well as we cannot blindly support this AI system that okay, this will give me 100% result. So these are some of the situations where AI can be very disastrous or can be very dangerous to us. Okay, let's solve a use case. Here we will be solving a pneumonia use case, which will be identifying whether the person is having COVID or not. So instead of identifying or saying that he or she is suffering from COVID, we will be saying that there is a possibility of 90% or 80% or 70% or 20% that this person is suffering from COVID or not. So for this use case, we will be using Jupyter Notebook, and as a framework, we will be using TensorFlow and Keras. Here in this notebook, we are using a dataset from Kaggle.com. You can get the access from this link, and you can get the access to the entire data. For this purpose, we are using a classification problem where we will be providing the input data as an image, and we will be getting the probability of patient being a COVID patient or not. So first, let's import a package that is imutil. So what imutil does? Imutil does help in image processing, and it also helps in getting the path of the images. Okay, so we will be using that. So if you don't have this package installed in your system, I would highly encourage use this command colon pip install imutils to install this package. Since I have already installed it, I'm not going to execute this. So now next, load the packages. So we do load the necessary packages. Again, we will be loading some of the packages here. Now we have loaded all the packages. So next, what we are going to do, we are going to use the directory from where our input data is taken as a test data, whether it's a normal test data from train, it's a normal images will be going into this directory. Then we will be using a directory validation for normal. Okay, and then we will be getting all the image path into this, and then we will be creating a label normal, that is normal multiplication of total number of images that are present in this path. Similarly, for the test data, for the pneumonia data, we will be using this folder. Okay, and now let's visualize the some of the pneumonia data. Okay, so here these are the x-rays of some of the patients who are suffering from COVID. Okay, and then let's see some of the normal patients. So these are some of the normal patients x-ray. Okay, so some images are like rectangular, some images are having different shapes, so we need to normalize them. So now before that, let's do this. We will be loading all the images paths which are present in pneumonia for test, for train, and for validation. So now this is our directory input: chest, x-ray pneumonia, chest x-ray, test, pneumonia. This is the directory for the test data. Now let's visualize the data or the number of values which are present in the form of pneumonia patient data and in the form of normal patients. So here we can see that 1583 values are normal samples, whereas 4273 are pneumonia samples. So we can say that more than 50% or there is 2.5 percentage of, or we can say, for example, we can see that what is the proportion. It's more than double. Okay, so now let's randomly generate some normal samples. Okay, so these are some of the normal sample data. Now let's suppose print some normal pneumonia samples. So here in this code we are generating so these are the normal pneumonia sample data. So now let's divide our data into train and test with the help of train test split. So now we are dividing the data into first train and test. Then we are further dividing the train data into train and validation data. So we have divided the data. Now create a train DF, that is train DF is equals to PD dot normal NP dot transpose. We are feeding the train directory and Y train directory, file name and class name. So by doing that, we will be creating 3 data frame: train data frame, validation data frame, and test data frame. Now we will be coming into image generation. So we will be creating a image generator object where we are rescaling it to by dividing it to 155. So all the pixel values will be divided to 255. Then zoom range. What is our zoom range? Zoom range is 0.1%. Height shift range is 0.05. Width shift range is again 0.05. And the rotation range, what is the rotation angle? Rotation angle will be 5. Similarly, we will create a test data generation. Here we are not going to add these properties, but we will be rescaling it by dividing it to 255. Then we will be using the data gen dot flow from data frame. Since we have the path that is stored in this train data frame, validation data frame, and test data frame, so we will be creating a train generation, validation gen, and test gen. Okay, so now since we know that X-ray images are grayscale, most of the images, so we will be converting all the images into grayscale images. Batch size is nothing but which we have defined earlier, that is 32. So now next, the class mode. Since we are classifying the image into a COVID or non-COVID, so the class will be binary. So shuffling is true. Similarly, we will be creating more data for validation, more data for test. So we can see that 4099 images, validated images found in 2 classes. That is for train, then this is for validation, and this is for test. So now we will create a TensorFlow dataset for more efficient training. So we will be using df.data.data frame from generator. These are the generator we have generated. So we will be creating train data from this train generator. Output type is float and integer. Okay, since we are giving input as a float and we are getting the output as 0 or 1, so that will be integer. Then output shape is 512 512 cross 1. That is the input size of our image. In the initial images of COVID patient and non-COVID patient, we saw that the images were not like same. Some of the images were smaller in size, and some of them were larger in size. So we need to scale them into one group. So that's why we are changing them into 512 cross 512. Similarly, we will be generating data for validation data and test data. Now execute this. Now we are creating image to augment. Okay, so we will be creating some of the augmented images. Okay, so image augmentation is nothing but by performing the image augmentation, we generate more images. Suppose since we have lesser data if in one class and more data in the another class, so by doing this we generate more sample data, which helps us in improving the model performance. So now let's plot base data. This is our base image, and by tweaking some of the values in the pixel values, we are transforming, or we are getting an augmented data. So some of the augmented images can be seen here. So here what we are doing, we are using image to array from Keras pre-processing image. Then to this image dot array to image, since we like we have images, we have transformed them into pixel values. So we will transform those array to image, okay, with the help of array to image and a image to augment function. This image to augment, we will be using this object here, and we are providing the range. Since we want to present two outputs, so we will be doing this to an interpolation, we will be using as a nearest, okay, and then we will be printing them as a base image and augmented image. So we can see these images. Now we will be using feed data. So what feed data does here, it's written here, feed data to model with prefetching. Okay, so argument, we are passing the data and we are getting a prefetched data as a output. So we will be passing this data set, and we will be returning a dataset dot prefetch. Buffer size is tf dot data dot experimental dot auto tune. So what it will do, it will auto tune that data and it will give us a data set. Now next we will be creating a trained model. Okay, so we will be, at the result we will be getting a model. So this is our input layer, where we are, our input size is 51 cross 512. Okay, and we are naming it as a input. Then we are creating our first convolutional layer with filter 64, kernel size 3, activation function as relu, padding is same, and we are naming it to conv2 1 underscore 1, and we are providing the input layer to this, and it creates a dot product of the neurons, okay, and then with the weights, and then we create a new x layer by providing max pooling to it, okay, and then we are adding a dropout layer. Next block, we will be creating a convolutional 2D block. Then again to that, we are applying max pooling and a dropout of 0.1%. Then to the third block, same activity we are doing. To the fourth, fifth, sixth, seventh, we are doing all the same. And at the end, we are getting a global averaging pooling. Okay. And to this, we are getting output, okay, layer dot dense, unit is 1, okay, and we are applying function as activation function as sigmoid, and we are naming it to output, and to this pooling value we are providing as a input, and then we are creating a model to it, and then that model is compiling here with optimizer as Adam. And since it's a binary classification, so loss is binary cross entropy, and accuracy is matrix is accuracy. So now create a object of the model. So we are creating a object of model here with the name model. Let's summarize this model. So we can summarize it here. So this is the summary, that type of the layer, output shape, and the parameters. So once we get this, let's visualize this with the help of Keras utils dot plot model. Okay, so we can see the how model looks like. So this way we can visualize our data, how the model are changing and how the inputs are changing to each layer. Okay, and at the end we are getting a output dense layer. Okay, to this we are adding a learning rate decay. Okay, so what we are doing it here, we are creating a scheduler. Okay, so with epochs, and by looking into the loss of the like model, we are reducing or increasing the learning rate with the help of this lr decay function. Okay, So LRDK is initial learning ROS into numpy dot exponential of minus of 0.1 into epoch. Okay, number of epochs. Okay, so now next we are creating a learning scheduler, this LRDK. Okay, with the help of learning rate scheduler function from TensorFlow. Okay, and then we are logging the CV logger. Okay, the how model is converging and how model is giving the result to us after each epoch. Okay, and then we are defining a model checkpoint. So what model checkpoint does? Model checkpoint is very crucial process while we are defining any model or we are training our model. So suppose you trained a model for 500 epochs. Now what happens that when you are training your model to 500 epochs, this may happen that the 500th epoch which executed was the reason behind the overfitting of the model. And what model you are getting is not a good model, it's a biased model. But what model checkpoint does? Model checkpoint to every like execution of epoch, it checks what is the validation loss, whether the validation loss is greater than last one or it's a less than the last one. If it's a greater than last one, that means this epoch was not optimized or not converged the model this time. Okay, so it will not store this model weight into the system. By doing so, ultimately what we are getting the most correct model weight from the model, and that we can use it further to predict the model, which will give us a better result. So now we are defining the model checkpoint here. We are saving each file name with this name, where we will be providing the epoch, number of epochs, then what is the validation loss for that, so that we can keep a track of the model's performance. Then as a monitor, we are using the validation loss. Verbose is 0. We are saving only the best model. We are not saving all models. We are saving the best models, and that too we are saving the weights only. So next time whenever we will be using that model, what we will be doing, instead of just doing the or instead of loading the model, we will be creating a model, and that weight, this saved weight, we will be loading to that model. Okay, and then we will be doing the forecasting or prediction. So mode is minimum. Since loss, if loss is higher, that means model is not converging. So our mode will be either it will be auto or it can be minimum. But here we have set it to minimum, and save frequency is epoch. Okay. Now next we are creating a train step and validation step. So in each epoch, what will be our train step and validation step? So if we see the train step, we can see this train step output, and with the help of model.fit, we will be training our model, and we are storing the all the information to this history. Okay, so now with this model.fit, we can feed the data here. Okay, we are calling the feed function, and to this feed data we are providing the train data, and from that we will be prefetch the data. Okay, and then we are setting up the number of epochs. Okay, we can change the number of epochs based on a model's performance. Okay, and then step per epoch, that is our trend step. Validation data, that is your feed data to the validation data. Validation step is which we have defined it here, validation step. And then shuffle is false. Then callbacks, what are the callbacks? That is, one is LR scheduler, uh, another one is CSV logger, and the next one is model checkpoint. So once we execute this, we will execute all the epochs, and at the end we will be saving the best model. But for the sake of time saving, we have already trained the model. Okay, and we will be now loading the model's weight here. Okay. Now, what we will be doing, we will be deleting our model since we have trained it already. Okay, so we will delete the model. Then we will create a new model, that is model, using create model function. And then to that model, we will be loading the pre trained model weight, where we have executed it for this number of what was our loss, okay, active validation loss, with what was our epochs for that second epoch. Okay, so now this is our train data, which is already we have with us. Okay, and to this df, we will be passing this to train generator, and we will be creating a test set steps. And to this model dot evaluate, we will be passing the test data and steps as a test step. Once that is done, we will be creating augmented data from the test df, and then we will be creating a test augmented data from test augmented generated data. Okay, and to those we will be applying the model dot valid evaluate. So while with this, we can see that the results are coming 0.34 and 0.86. So now we will be creating a precision recall, and we will be generating confusion matrix out of it. Okay, so the help of tf.keras.matrices, we are calling precision recall, and we are creating an object of that precision and recall. And then with the help of model.predict, we are passing the test data, and we are getting the predicted results. Okay, and to that we are passing the y true. Okay, and then precision and update, precision and recall update state, and we can see that the precision of this model is 0.69 and the recall of this model is 0.65. So from this we can say that the model is not the best one. Okay, we can further train this model by applying the feature enhancement in our image data, and then we can get the best result out of it. Then now let's focus on this process next. So we will be creating a confusion matrix out of it. So we will be passing a y-train and prediction results. Okay, and here we are with the help of C-bond, we are plotting a confusion matrix for pneumonia and normal. Okay, so now we can see that normal people, how we can read this as a, the normal people which were actually normal are 65. The normal people who were considered as a by model, it was considered as a pneumonia, were 175. Okay, then those people who have pneumonia but were considered as a normal was 211. And then we can see that the number of person who were identified the model as pneumonia and were actually having pneumonia was 396. So from this confusion matrix, we can see that it's a alarming situation where model is saying that 211 people are normal, but actually they are suffering from pneumonia. So in such situations, we can say that model is model is not performing well, or we can say that in such situations, if we rely on only AI, then in these situations this can be very dangerous to us. Okay, now let's plot the image with percentage of possibility that whether the person is having COVID or not. Okay, or pneumonia or not. So we are using the plot image function here. We are creating a function. Okay, and what we are doing it here, we are using the image to array to image, since we have converted it into an array. So from those array to image, we are using matplotlib to show the images. Okay, in grayscale region, in grayscale. Okay, if prediction is the output, or the percentage of prediction which we are getting is lesser than, or is lower than 0.5, we can say that the person is not having COVID, or we can label it to 0. If the level is, if it is greater than 0.5, or then we can say that the predicted level is 1. Okay, and if predicted level and label are true, color it with blue, else color it with red. Okay, so now, and at the end we are providing the labels to it. And now let's suppose we wanted to plot 3 cross 3 images. Okay, and these images are taken from text data, data, okay, random data. Okay, and we are feeding these data, so we can see that there is the model is saying that 100% it's a pneumonia. There is a normal 90% probability of normal. Pneumonia is 70%. Pneumonia is 100%. Pneumonia is 25%. Pneumonia is 60%. Okay, then again it is here, it is showing this with the color red. Okay, pneumonia is 16%. Okay, so that means we can say that it's a misclassification here. Okay, so a normal 25%, which is normal actually. Similarly, pneumonia 90% model is saying, and the person is suffering from pneumonia. Okay, now we reached the end of this course. So in this course, we discussed what is AI, what is machine learning, what is deep learning, then various types of machine learning like supervised machine learning, unsupervised machine learning. Then we also see how regression or classification can be solved with the help of Keras and in deep learning. Then we also discussed some of the functionalities of deep learning, or how actually deep learning works in a broader way. Then we also covered some of the portions like what are the applications of AI. Okay, like Google Assistant, Google Translator, Google's Smart Compose, self-driving car, and things like that. Then we covered what are the applications of AI in healthcare, or how AI is improving the health services. Then we also covered some of the gray regions of AI, where AI can be very dangerous in terms of in the field of healthcare if we blindly follow the healthcare with AI only. Okay, then we solved a use case of whether a person is suffering from COVID or pneumonia or not. Okay, there also we discussed that what could be the possibility, and we saw that how model is not performing well in some of the scenarios, and how this can be dangerous if we follow the AI only in identifying on in predicting the disease. I hope you enjoyed this course. That's about it from this course. I would like to end this course with a term like either one day or day one. Okay, it's up to us whether we want to study in one day. One day I will study, or I will study from this day. Okay, so with this note, I would like to conclude this session. So keep learning, keep growing. Till then, bye bye.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.